On this video I will be doing this exercise, right? This one and this one. The reason why I jump these ones, it's because to me they all basic, and if you can go to other tutorials where I was doing industrial electronics exercises applying Kirchhoff's law, you would get enough knowledge that would assist you with these. They are easy, except for this one and this one. So the reason why I'm doing these ones is um, here we've got three unknowns, unlike these ones where we are calculating I1 and I2. Here we are calculating I1, I2, I3. Same here, I1, I2, I3. There is a difference between this second and this second. This one is a resistor in series with this battery. So there is no resistor. So if you would consider this loop, you would include this resistor. That means you would use this current. But on this loop, since there is no resistor here, the current that is here, you will not include when you are making an equation of this loop. If you want to, you can attempt to calculate this one and this one. If you don't get this, then you come back and watch my video and see how we calculated this current. Here they are saying in the circuit shown, calculate the current flowing through the 1 ohm resistor, neglect the internal resistance of the battery. We will not calculate only this current on this video. I will also calculate I1 and I2. Even on this one, or on this one, they said let's calculate all the currents. So let us start with our calculation. Before everything, we would need to redraw the circuit. Our circuit had that resistor, which is 2 ohms resistor. We then have another resistor, which is 3 ohm resistor. We then have another resistor, which is 4 ohm resistor. We also have this resistor, which is 5 ohm resistor. We then again have this resistor in the middle, which is 1 ohm resistor, and it's the one that they said we must calculate. Our cell is 2 volts, 2V here. So on this circuit, when we've seen that our textbook, in most cases, they are using conventional current flow instead of electric current flow. So we will just use conventional current and say our current is from a positive terminal to a negative terminal. So what happens there, we know that the current will split, take that direction and this direction. And there we know that a current will split again, it will take this direction and this direction. So we know that these currents add here and they take this direction, and the current here will take this direction. So they also add there, we'll have a current through this direction. Now what we need to do is to name our current. So let's say the current here is I1 and the current there is I2. It doesn't matter, you can make this I2 and make that I1, but you must remember that this one, even this one, I wouldn't say you must make it I3. If you decide to make that one I3, then you should know that this one will be I2 minus I3. So since we made this one I3, then this one would be I2, the big current, minus I3, the current that splitted on that current. So if we want this current, we said this current and this current will add here. So a current that is flowing here is I1 plus I3. So what is the current here? We said this is I1 and I2, so it would be the sum, I1 plus I2. But when we're taking this loop, we won't use this current because we are told to neglect the internal resistance, and we don't have any resistor here that is connected in series with this battery. So now that We know the currents, we know the directions. We are now ready to do the calculation. Let's do the calculation. Oh, before that, let us name the loop. Let us name the circuit alphabetical. Let's say this is A, B, C, D. Some will say A, B, C, D. Doesn't matter. So let's take this loop, which is A, D, C, A. This A, D, C, A. So this loop, we have two resistors and we have the cell. So we'd say 2 volts equal to the resistance there, which is 4I1. And we are going to the same direction even here. So here we've got 5 ohm resistor. We would add and we would open the bracket, put I1 plus I3. Here we have 4I1 and we would have 5I1 plus 5I3. We then have 9I1 plus 5I3. So this would be our first equation. So another thing that you should know, when you have three unknowns, you won't make two equations, you will make three equations. So let's go to another loop. Which loop we should take now? Let's just take A, B, C, A. So that means we are taking this loop if we don't include D. Then we're taking A, B, C, A. On this loop, we have the cell again, which is 2 volts, and we are going out now. We have 2I2, and the direction is the same, so we have plus 3 into I2 minus I3. So we would have 2I2 plus 3I2 minus 3I3. So here we have, what do we have? I2 plus I2 will give us 5I2 minus 3I3. So this is our second equation. So let us now go and make our third equation. So our third equation, which loop we will take? Let's take, we took A, B, C, A. Let's now take A, B, D, A. You can also take this one, it doesn't matter, B, C, D, B. So we say we're taking A, B, D, A. It's just gonna make this video long if I take both loops. Okay, on this one we don't have a cell on this loop, right? What we have is 2I2, and we are going to the same direction, so we have 1I3. So we won't put 1, but let's put 1 in case someone is missing something. So this is going to the different direction now. So we'll have minus 4I1. So this becomes 2I2 plus I3 minus, let's say I2, sorry, I1. So this is our third equation. So what we do after that, we looked on our equations, which equation will make things easy for us if we go to and either make I2 the subject of the formula. Let's come here. If we make I1 the subject of the formula, we'll have to divide by 9. So that will make us work with fractions. If we come here and we say we make I2 or I3, we've got numbers 9, 5, 5, 3. So we will be dealing with fractions. We're not afraid of fractions, but we just want to simplify things. If we come here, and make I3 the subject of the formula, we will not be working with fractions. Sorry. So let us make I3 the subject of the formula. So we will say from equation 3. From equation 3, what we do is make I3 the subject of the formula. So if we take this to this side, this will become negative and this will become positive. So we will have I3 equal to, let's put this one first since it's going to be positive, 4I1 minus 2I2. So if you want to, you can just take this I3, substitute this I3 here, and substitute this I3 here, because we have I3. And now, where does this helps us? Once we substitute I3, we are putting I1 and I2. We've got I1 there, we've got I2 here. So this makes us have two unknowns, which take us back to the kirchhoffs that we are familiar with. So that is what I just do. Some will not use my method. Like from here, what they will do is they will make this equation 4. Yeah, let's make it equation 4. So some will take this equation 4 and substitute this equation 4 on equation 3. And after substituting equation 4 on equation 3, they will then get equation 5. And after doing that, equation 5, they will continue to make equation 6. Equation 6 will not be made from equation 5, will be made from equation 1 and equation 2 by subtracting equation 1 to equation 3. So then they will have equation 6. After having equation 6, then they will continue. It's hard to tell it theoretically, but if you know it, you know it. But let's just take my method for this one. I said we will take I3 and substitute on equation 1 and equation 2. So you say substitute equation 4 in equation 1 first. So here we've got 2 equal to 9I1 plus 5I3. So this I3 will be gone on our second step. 9I1 plus 5. Where is I3? We said I3 is equal to 4I1 minus 2I2. We then end up having 9I1. This would be 20 plus 20. I1 minus 10 I2. So this will give us 29 I1, and we would be left with minus 10 I2. So let us call this, the last equation was equation 4. So this one is equation 5. We again substitute equation 4 in 2. Equation 2 is 2 equal to 5I2 minus 3I3. So this becomes 2 equal to 5. I2 comes back. I3 is replaced by 4. I1 minus 2I2. So here we will still have 5I2, and here we will have minus 12. It's going to be 12, right? I2, and here it will be plus 6I2. So here it's I1, sorry, not I2. So I1 or I2 and I2 will add and will give us 10. So and that 10 is positive, so sorry, it will give us 11 I2, and the minus 12 I1 will remains minus 12 I1. So this is equation 6. So now what do you see? It's what you know. We've got only two unknowns. So if we want to, we can make I1 the subject of the formula. So let's make I1 subject of the formula here and have equation 7 to substitute in equation 5. So this is what will happen. I1 will be equal to, I1 will come to this side and be positive, and 12I1 will become this side and be positive, and 2 will come to this side and become negative. 12 will divide here and divide 2. So we'll have 11 over 2 I2 minus, sorry, divided by 12. We said we're dividing by 12, minus 2 divided by 12. So that is what we'll have, and we know that 2 divided by 12 is the same as 1 over 6. So this is gonna be equation 7. So we take this equation 7 and we substitute it there. I've ran out of space. Let me take this paper and continue on it. So we said what we will do is we will take we will substitute equation 7 in equation 5. So equation 5 we said is 2 equal to 29. We will replace I1 by 11 over 12 I2 minus 2, let's say 1 over 6, because 12 2 goes to 2 1 and to 12 6 times. We will then have minus 10 I2 minus 10 I2. So this becomes 29 times 12 times 11, sorry, is 319 divided by 12 I2 minus 29 divided by 6 minus 10 I2. Now this one will come to this side, and this is what we'll have on this side. We'll have 2, this will become positive, plus 29 divided by 6, and this becomes 41 divided by 6 equal to, here would add, no, we're minusing, so we have 319 12 minus 10, because positive and negative will subtract. So 319 divided by 12 minus 10 is equal to 199 divided by 12 I2. So this is cross multiplication. This one will go there, and this one will come to the bottom, because we want I2. So if you want to, you just say, because this one is dividing here, so if you want to, you just say 41 divided by 6, then you say divided by 199, and you put 12. Then I2 would be 0.412 amperes. So if we know I2, we can substitute I2 now here and get I1. I1 would be, let's just store this on A so that we don't give final answers that will be different, because if you round off and put this one, that might make the final answers different. So we will have 11. Okay, they will have 11 times I2. We found that I2 is what we stored on A, which is this, and divided by 12. So we would minus by 1 over 6 or 2 over 12. It's the same thing. So our I1 is 0,211 amperes. So we want I3. When they said let's calculate a current across 1 ohm resistor, they were asking us to calculate I3. So how can we get I3? The only way for us to get I3 is to go back to our equations and check where we have I3. We had I3 here, we have I3 there, and we also have I3 there. So we can take any and substitute and get I3. We also have I3 there, right? Yeah. Oh, we substituted then. Oh, this one was coming where? Substitute equation 4. There is equation 4. That one makes things easy for us. So let's just take equation 4 and substitute. Let's store this answer to B. So we know that B is I2 on our calculator memory. So I3 can be calculated by 4 times I1, which is B on our memory, minus 2 times I2, which is A on our memory. Then that is I3. So I3 is 0,02 amperes. We were going to round off to 1 year if that was 5 and more. So we got the answer that was written on our book, which is 0,02 amperes. So now let's continue and calculate this one. The only difference we said is that this one is a resistor. So let's go. I have this circuit drawn, and what did really the question require us to calculate here? It said we must calculate in a Wheatstone bridge network shown, find the magnitude and the direction of the current flowing through each resistor. The EMF of the battery is 4 volts. Assume the current flow in the direction indicated by the arrows. So you see, they're using conventional current. I think here you will just take what they have written here, but then we are used to know this longer leg is positive and this one is negative, but our concern is only the current direction that they have given us. So they said we must also find the magnitude, but that's what I hate about the book with answers, because now if they gave us answers here, they also give us the magnitude. So let us calculate the currents I1 and I2 and I3. So here, if we want to calculate I1 and I3, we will need to name the circuit. Oh, they named it for us. They said A, B, C, D. So let's put A here, A, B, C, D. So which loop we will be starting with here? Let's take about this loop A, C, D, A. So this loop A, C, D, A, as 4 volts battery, and as this resistor, which we're told that this resistor is 1 ohm. So here, when we're taking this loop, we've got 3 resistors. The current direction is very important. Here it's going down. So if we come here, we've got I2, so we'll have 4I2. And if we come here, we've got I2 plus I3 across this 3 ohm resistor. So the direction is the same. We would say plus 3, then I2 plus I3. Now we need to come to this resistor. The direction is the same, plus 1 into I1 plus I2. I1 plus I2. So that's it. So now we need to simplify this. This becomes 4I2 plus 3I2 plus 3I3 plus I1 plus I2. This will add, right? So this would be 7 plus this, it would be 8. So we'll have 8I2. I just want to put them on their order since everything is positive here. And the I1 is alone. So we would have I1 in front. Sorry, I1, not I2. I don't know why I keep making these mistakes. I3 is also alone. So we'd have 3I3. So this would be our first equation. Which loop we're gonna take now? Let's take A, B, C, A. Remember, when we're taking this loop, we don't have a cell. So A, B, C, A. So 0 is equal to, we've got that current going that direction across across 1 ohms. So this gives us I1. And we've got this one on the same direction, so we add and we have 5I3. We've got this one on the different direction, so we minus. We will then, the current there is I2 across 4 ohms. So this is what we would have. So someone would say I1 minus 4. I2 plus 5I3 is just the same. So this is our second equation. On our third equation, let's take this one, since on the previous one we took that one. So let's take B, C, D, B. Here we don't have a cell, so this is 0. If we're taking that current is positive, and this one and this one will be negative. So if we're taking these ones as positive, that one would be negative. So what do we do? In this case, we need to make a decision. Remember that when we were here, we took this direction as positive, so we can't change that. So let's take this direction as positive. So we have 5I3. And here we have 3 ohm resistor. The direction is the same, so we add, and we have I2 plus plus what? Plus I3. My mind just stuck. Then we said we're taking that direction as negative. So here we have 2 ohms and we have I1 minus I3. So this becomes, I just want to use the space ones. So this becomes plus 3I2. and this becomes plus 3i3, and this becomes minus 2i1, negative negative makes a positive 2i3. So we can see that i2, the only i2 we have is that one. I1, where else we have I1? The only I1 we have is that one. So I3, I3, I3. So let's write the final equation. Let's just start with minus 2I1 and follow by I2, I2 plus 3I2. So what's happening on I3? We've got 5 and we've got 3, that's 8 positive, that's positive 2, so we'll have plus 10I3, and this would be our third equation. Again, which equation, if we go to, it would be easy for us to get I1, and if we, or I2 or I3, and when we do so, we will not be having fractions. So if we come to equation 2 and make I1 the subject of the formula, things would be easy for us. If we come on here, we would have the number there, so that would make our calculation bit hectic. We're not afraid of that, but we want to simplify things. So we're saying from equation 2, we are making equation 4. So equation 2 is 0 equal to I1 minus 4I2 plus 5I3. So what we're gonna do is we'll take these to the side and every sign changes. This is the same as I1, ba, ba, bum, 4I2 minus 5I3. So this is now equation 4. So what we will do is we will substitute equation 4 on equation 1 and equation 3. So let's do that. Let's do this here. Substitute equation 4 in equation 1 first. So where we have I1, we just put that. So I1, so we put that 4I2 minus 5I3 and plus 8I2 plus 3I3. So what do we get here? We've got I2, I2, all positive. So we'll get 12I2. Sorry. We then have this one, I3, I3. This one is negative and this one is positive. So we'll have minus 2 I3. I must take this call. So I always say I'm an appliance technician. So since I am fixing appliances, I get calls a lot to come and assess, to come and repair, sometimes the written jobs. So you will have to forgive me when my phone rings and I attend it, and that takes us away from what we're doing. So where were we? We were here, right? So we just saw that this leaves us with I2 and I3. Hopefully, when we substitute again our equation 4, let's continue. Substitute equation 4, where we made equation 4 from equation 2, so we'll substitute on equation 3 in 3. So let's see what we get on 3. We have 0 equal to we're substituting equal I1, so we have 2 into that, which is 4I2 minus 5 I3. So we have plus 3I2 and plus 10I3. Definitely we're gonna have I2 and I3 at the end. So here we will have minus 8I2, and here would have plus 10I3. There would have wow, something is going, oh no, it's not gonna happen. Plus 3I2 plus 10I3. I wish this was negative, but it's not happening. Okay, let's continue. Bam, ba, bam, ba, ba. No, why I'm changing the color now. So we have, oh, we said that one, if we're in equation 4, let's call that one equation 5. And what we'll have here would be, we have I2 negative and positive, so this leaves us with minus 5. Yes, minus 5I2. We have I3, they all positive, so plus 20I3. So this is equation 7. So this is what we know when now here we've got only 2 unknowns. So we can either there or here make one the subject of the formula I2 or I3, then we would substitute and get the other. So let's say from equation 7, let's take equation 7. I just like equation 7, which is 0 equal to minus 5I2 plus 20I3. Which one you want to? I want to take this one on this side, and we will have I2, we'll have 5I2, and we'll have 20I3. So we'll divide by 5, then I2 would be equal to, if you divide by 5 here, you get 4I3. So I2 is the same as 4I3. So we can take this I2 and substitute it there. After that, we would be able to get I3. So let's make this equation 8. So substitute equation 8 in equation 5. So we will have 4 equal to 12, and we'll open the brackets. We'll have 4I3, and we'll have minus 2I3. So this gives us 4 equal to, this is 48. 48 I3 minus 2I3. So this becomes 46, right? Because now this one is negative. So we have 46 I3. So I3 is gonna be 4 divided by 46. Sorry, 46. I don't know why I wrote 48 again. So it's gonna be 4 divided by 46, which will give us what? It's giving us 0, 0,08 69. So we'll round off that one, so we'll end up having 7 here amperes. So let's do this. Let's store this in memory. So I3 is gonna be stored in A. So we know I3, so we can substitute I3 there and get I2. I've ran out of space. Let's take this sheet again. So we said on 4 equal to 12, I2 minus 2 I3. So to get us To get I2 now, when we know I3, we will say 12. We take this to the side, it becomes positive. I2 is equal to 4 plus 2I3. So we know that everything must be divided by 12 for us to get I2. So it will be 4 plus 2I3 all divided by 12. So let's punch that in a calculator. So we will have 4 and we would have plus, and we'll open the brackets and say 2 times I3, what we recall, it's here on, we recall what we stored in A, and we'll divide by 12. So what is the answer? It's 0.348 to round off in there, amperes. So is there a way for us to know I1? Definitely, there is a way to know I1. We can use this equation. So we'll then say we'll then use this one, and minus 5 by 3. So let's just punch this in a calculator also. It's 4. Oh, my mistake. I should have stored that. What we got here, I should have stored it in memory. But this calculator doesn't want to remember it. So let's just substitute using these values that we got here. So we'll say for our I2 is, we said our I2 is what? Oh, our I2 is in front of me and I'm not seeing it. And we would minus 5 and put I3, which is 0.087. So let's put this in our calculator. 4 times 0.348, close the bracket, minus 5 times 0.087, and this is equal to 0, 0.957 amperes. So now to our circuit, we know that a current across AB is I1. So we would say AB equal to I1, which is 0.957. A current across AC, it's I2. Oh, it's I2. So AC is 0.348 amperes, and it's in this direction. And what else? Another current across BC this direction, and is it's gonna be I3, and our I3, we found that I3 is that 0.087 amperes, sorry. So we're done with this. Let's come here. BD, I1 plus I1 minus I2. So I1 is 0.0957 minus I3. I3, we said I3 is 0.087, and this is gonna be 0.087 0.87 amperes. So CD is gonna be I2 plus I3. So I2 plus I3. So let's add 0.348 plus 0.087. So what we're getting there is 0.435. And now we want the current here. So the current here will just say dA. Once we leave C, we're not here, we are there. So a current on dA. What was the current on dA? It's I1 plus I2. So we saw that I1 is 0.957 plus I2 0.348. And dA is 1.305 amperes. So let us check if we did got what they got here, because now this clever book gives us answers. So AB is the same, and BC is the same, and CD is the same, and DA the same, BD the same, that one the same. So we won. If you want me to do this, just leave a comment. I will do them, but I will check how many people that requires me to do that. For example, maybe if plus minus 5 people want me to do them, I will do them. Thank you. Don't forget to subscribe, like, comment, because liking, subscribing, commenting, it's what will keep us going, because we will be aware that with these tutorials there are some that are being helped. Even if it's a one person, we will continue with these videos, because someone will be helped by these videos out there. Thank you.